history of Scipy. Scipy is a free and open source Python library used for scientific and technical computing. It is a collection of mathematical algorithms and convenience functions built on Numpy extension of Python. It adds significant power to the interactive Python session by providing the user with high-level commands and classes for manipulating and visualizing data. As we know, mathematics and scientific research are the ruling domain in every era. To solve all those problems contained in them, we can make use of this module Scipy. It is an open source scientific library of Python under BSD license. It is very easy to use, provides great flexibility to scientists and other engineers. It can be used for various kinds of scientific and advanced level mathematical concepts like Fourier series, Fourier transforms, integration, single integration, double integration, with limits, without limits, and various kind of advanced mathematics, and also for scientific researchers also, which makes the programmers like data engineers or any other using this module, it will be very easy and convenient for them. So that is, as I said earlier, it's built on top of the Numpy extension, which means that if we import this library, there is no need to import Numpy. So this is a diagrammatic representation of various modules in Python. Now coming to installation of Scipy. Before learning more about the core functionality of Scipy, it should be installed in the system. Install on Windows or Linux. So here are the few methods that can be used while installing Scipy on Windows or Linux. If I have to use, here I am using Windows system. It can be installed on any IDE or code editors. I am using here Google Colab. Jupyter Notebook is also very user-friendly code editor, which is another alternative for Google Colab. So I am using the command called pip install Scipy. So this is the command which has to be used to install the Scipy module. So once we enter this command, and this is called one cell, and this is a Google Colab. So here after entering this command, I can run the cell. So we have to wait. This means it's running, cell is running. So I've already installed this Scipy module in my system, so it says already satisfied. So this library already exists in my system. So now one more, if we have to test, so this is the small, this is how we install Scipy module. And then why is it used? It can be used for mathematical algorithms, which provides easiness to develop convenient and dedicated applications. As its open source library, a large community of people across the world can be used to develop its additional module, and it's very beneficial also. Scipy is built on Numpy. So if I import this Scipy function, I need not import Numpy. So Numpy and Scipy both are used for mathematical and numerical analysis, where Numpy is suitable for basic operations like sorting, indexing, and very basic operations, and for advanced and complex operations and calculations we can make use of Scipy module. So this is the basic difference between the Scipy and Numpy module. We have various sub-packages under Scipy. So here we have mentioned few. For example, scipy.cluster, scipy.constants, scipy.io, optimize, signal, spatial. So and here are detailed description. For detailed description, you can go to the official documentation. So here a very brief description is given, and for each sub-package. For example, if I take scipy.cluster, cluster algorithms, they are used for vector quantization, k-means algorithms can be used. And if I use scipy.constants, it represents the physical and mathematical constants. Scipy.interpolation, it is used for interpolation functions. For linear algebra, we can make use of this sub-package, and for optimization we can use optimization, Scipy.optimization subpackages, and these are the few. This table contains subpackages under Scipy, which can be used for as per our needs. For detailed documentation of these subpackages, we can refer the official document. So next, coming to the basic functionality, all the Numpy functions are available and through the Scipy namespace. So there is no need to specially import this Numpy library, because Scipy is already built on that. So additional installation of Numpy is not required. So if you install Scipy, that is enough, as it also includes Numpy functions. Numpy can be used for very easy basic calculations, and Scipy can be used for advanced and more complex operations like Fourier series, Fourier transformations, and integration, single integration, double integrations, and many more. So this is the optimization in Scipy. Various functions for finding roots, for curve fitting, for minimizing the curve, and various other optimizations Scipy can be used. Now, to convert the Python array objects to Numpy, we can make use of this following code. Import Numpy as np. Here we have the list. List contains 5, 6, 7 as the values, and then here we are converting these objects into Numpy. So as we can see, this is actually a Python array like object which has been converted into Numpy using this following code. So this is an ecosystem of Scipy, where it has library, Numpy, pandas, matplotlib, Python library, and this one, SymPy. So this represents symbolic mathematics. Matplotlib, it converts 2D plotting, comprehensive 2D plotting. We can make use of this. And for pandas, can be used for data structures and analysis. Numpy can be used for n-dimensional array package, and so on. So using zeros, these are the intrinsic array creation. We can make use of the following functions. First one is zeros. Using zeros, this function basically it will create an array filled with 0 values specified in shape. The default data type of this is D type is data type. It is default data type of this function is float 64. So import Numpy, same code as we used earlier. Import Numpy as np. We are printing the numbers from 0 to 3. So the zeros function, that means what? It will create the array filled with 0 values as shown here. This is similar to that of zeros function, but instead of 0, here 1 will be printed instead of 0. So this will also create an array similar to the previous one, but it will fill with the 1 value, the identical zeros and other respects. So whichever things which is not filled with 1, other things are filled with zeros. So this is the usage of the function zeros and ones. So there are various other important packages when as file input and output package can be used as mentioned in this sub function. We have input and output stuff. This is one of the sub package in the Scipy module. So this sub package, this table basically contains all the sub packages under this module with a brief description. So same thing here, file input and output, wide range of functions we can use, formats like MATLAB, Wave, Matrix, and so many other things. So special function package or for mathematical physics calculations can also be used under this module, like cubic or quadratic. Roots can be found out just like scientific calculator. These can also be done using this module. This is for cubic root. Also we can use quadratic, and to raster the Numpy array, to convert it to feature class and the tables and so many other complex advanced mathematical calculations. Exponential function is also one of the advanced mathematical can be found out using the Scipy library. So initially we have to use from, which is a keyword. So this is the code. This is a small code used to find the exponential function using the Scipy module. So here they are finding the exponent of 1, 10. So this is the function and we are printing it here. So this is the output for the above function. And permutations and combination. The permutation and combination is another advanced mathematical example used using this Sci-Fi module. So permutation and combination, if you are going to use the mathematical representation, if you are going to calculate it using the textbook formula, that is n factorial by n minus r factorial, here we have 5 and 2. 5 is n, 2 is r. So 5 factorial by 2, 5 minus 2 factorial, that is 5 factorial by 3 factorial, we will get the output as 15. So this is a small example related to Python, that is Sci-Fi usage by using the module that is Sci-Fi. After the importing, we can make use of that module to calculate another advanced mathematical calculation, that is for permutation and combination. It can be used for exponential function, it can be used for cubic root or finding quadratic roots. So these are all the various examples. It can be used for Fourier series, Fourier transformations, integrations, and many other advanced calculations. So if I have to show it in the code editor, so here as a simple example where I have done the single integration, first initially we have to install this module, that is Sci-Fi. Once it is installed, we can make use it for various other calculations. For example, if I have to use it for permutations example, so initially I have installed this library and I am finding the 5,2's permutation. So after writing the code, here I am running the cell. I can press this small triangle shaped arrow mark here, or I can press Ctrl and enter to run the cell. So I got the output 20 as the answer for the permutation value of 5,2 using this Sci-Fi module. This is for permutation, and similarly for combination, if I have to find the value for n, r combination, that is 5,2 combination, if I have to find, if I run the cells by pressing Ctrl and enter together, or by running the cell directly here, we get the answer as 15. So using this Sci-Fi module, after importing it, after installing it using this first step, we can perform various other calculations like this. This is the permutation example and this is the combination example, where I have done this using the Google Colab. Any other code editors like Jupyter Notebook is also user friendly. As per the user requirement, we can make use. So coming back here, permutation and combination, this is the log sum exponential function we have done, and example for integration. Sci-Fi can also be, it's extensively also used for integration calculations. So we have single, double and triple integrations, which will be slight difficult, or it might be more than basic operation for the user or the programmers to calculate. So that then also they can make use of this module by importing it. So here is the basic general representation of an integration, that is integral of f of x dx. F of x can be any function, it can be of sine function or any numerical function running from the limit a to b. This is a and b are the upper and lower limits respectively. So similar to that of double integration, we can also have triple integration also. This is the function, that is f of x, two integrals, limits a and b, upper and lower limits. So now let's see the how does this work in the code editor. So here is a example, small example. If I have to find the integration of a to b, f of x dx, single integration if I have to find, here is a small example. So I'm running this code. After installing the Sci-Fi module, I'm exactly getting the value. So this value is the answer for the integration of this x power 2, that is the function from the limit 0 to 1. So doing this manually might consume lot of time. So using this is very easy, and also it's user friendly, open source module, so anyone, large number of people can also make use of this. And coming to double integration also, I have taken similar example but with two integrals. So upper and lower limit calculation is done, so and we have got the result as this one. So this is using the Sci-Fi module, we can find out, or we can make use it to any find any complex advanced calculations can be done. So similar to this of single integration, double integration, we can also use it for Fourier series and Fourier transform. So if you have love for numbers, this is where you have to be, because this Sci-Fi, basically scientific Python, it basically makes you it will be very helpful and convenient for the users to easily calculate, and within very less time they can arrive at the required results. So for the this is a short description, and here I try to explain by giving various examples. And thank you for patiently listening for this video. Hope you have learned something new. Thank you, DevIncept, for providing us this opportunity.